At the beginning, I want to thank you all for attending our webinar. Who doesn't know me, I'm Renata Kalniūnienė, Marketing Project Manager at MedDream. And today we have a joint webinar with our partners, Dicom Systems. And this webinar, as you know, is going to be dedicated for High Throughput JPEG 2000 in practice, and how this transfer syntax changes web viewer performance and what influence does on our workflow. So I want to present the agenda. So it's going to be a short introduction of MedDream and Dicom Systems collaboration. Our partner Dicom System is going to present this transfer syntax in practice, show demonstration how their product Dicom Systems Unifier platform works with MedDream Viewer. And in the end of the webinar, we are going to have a question and answer session. So as always, during the webinar, you can write your questions in the question and answer section. I'm going to collect all the questions and read in the end of the webinar. So from our side, today we have Marius Šadauskas, System Integrator at MedDream. He's going to present MedDream part in the end of the webinar after our partner's presentation. And also today we have Artūras Gruodis, Head of Integrations at MedDream. Probably he will be helpful in the questions and answer section, help Marius to answer more difficult questions related to the integration. And also the main speakers for today, our guest speakers from Dicom Systems, our longtime partner. This is Dimitri Tochilnik, President and CTO of Dicom Systems. He's going to do technical part of presentation. And his colleague, Florence Sinclair, Chief Operating Officer at Dicom Systems, he's going to present a short presentation of Dicom Systems solutions and short history and their business. So I'm passing my word to our guest speakers.
Very good. Welcome, everyone. So, first of all, Renata and the MedDream team, thank you for giving us the opportunity to present. I think this has been a long time coming. We've been partners for a very long time and never really got a chance to present together. I think this is going to be an eye-opening experience for some of us. So, first of all, Dicom Systems, has been in business for 18 years, and we're not a PAX company. That's what makes this an unusual partnership with MedDream, right? MedDream has been in the business of showing medical images for a long time. We've been in the business of providing the back-end plumbing that makes all of this happen in a way that improves performance for end users. So I wanted to give you a brief history of Dicom Systems and how we came to be the plumbers of the industry. Long time ago, when the US got involved in the Middle East, you can imagine a lot of medical attention needed to be given to soldiers who were injured in the battlefield conditions. And our job, this is long before we started Dicom Systems, several years before Dicom Systems, our job was to establish teleradiology technology in Iraq, in Afghanistan, in Kuwait, Navy ships, any place that the US military was running medical imaging operations. And the task was to use satellite communication to send massive amounts of medical images to Germany, in Landstuhl specifically, and Ramstein Air Force Base, which is where the majority of the Air Force radiologists would read for battlefield, also called downrange operations. Then ultimately, all of those images needed to go to the continental US. That's Walter Reed Medical Center, Brooks Army Medical Center in Texas. That would be Balboa in San Diego. It's massive global network of satellite communication to move a lot of very large files. And so what we learned in that experience was that PACS companies did typically a pretty good job for the physicians, but not necessarily, stellar support for the PACS administrators, the IT support, the network administrators, who were expected to maintain these workflows for the physicians and for the patients. And so, given the mission criticality of these operations, we decided to focus the attention of Dicom Systems on the back end. So our primary end user is not necessarily a physician. It's going to be a PACS administrator. It's going to be a network admin, an IT director, somebody who is expected to work with plumbing behind the wall. So our typical customers, actually a pretty wide range of customers. We're global in nature, but in the US specifically, we serve a lot of academic medical centers. We serve some of the largest IDNs on the planet. We're talking about Kaiser Permanente, HCA, each of whom serves dozens and dozens of hospitals across the US. We also have some of the largest teleradiology users here in the US, RAD Partners, OnRAD. It's a matter of how can this software scale from the tiniest little clinics in the middle of Alaska or Hawaii all the way to multi-hospital systems, right? So the same technology that we're going to show you in a minute is serving very small clinics that are very remote with perhaps a single technologist working 1 or 2 days a week with an ultrasound and an X-ray machine, all the way to very large hospital infrastructures with thousands of modalities. After 18 years in business, you can imagine we've had experience working with a vast majority of PACS vendors out there. Several actually resell our technology, which is a testament to the vendor neutrality of what we provide. Sectra, Infinite, Oracle, those are resellers of our technology. And by the numbers, this is what we did last year. The previous year, the slide actually read 98 billion images routed in 2024. And so from 24 to 2025, we experienced pretty significant growth. We expect this growth to continue as more and more of our customers are also adopting new types of medical imaging using our technology. We're talking about digital pathology specifically, which is super relevant to our topic today, right? The ability to use variable compression levels, transfer syntaxes to move massive amounts of medical images and present them in different contexts. So essentially, what we deliver ultimately, right, together with our partners is this vision that, has been talked about for several years now, which is precision medicine. And with the advent of digital pathology and genomics data and the advent of AI, with the ability to correlate massive amounts of radiology, pathology, and genomics data together, we'll eventually be able to actually present the data in a way that drug companies can develop personalized, targeted drugs for people, right? So at some point, we're going to stop providing drugs that are sweeping, supposed to be applicable to a whole segment of population. It's going to be, specifically, a drug for Florent, based on my genetic background, based on my current pathology, based on what my radiology images show. And so I'm going to turn the presentation over to Dimitri, who can, go into why these types of technologies need to come together. And Dimitri, please go right
Yes,
ahead.
hello. Yeah, hello everyone. So as the data set evolve, so we can see the AI. It's a new era of AI. Obviously, we heard that in every trade show, and but it is we know it's coming. So the data set getting bigger And this is we in kind of an intersection of the big data set and drastically increasing. So we're talking about the different subspecialties. If you think about it, the pathology, it's a great example, but there is also ophthalmology, dermatology, the data set is getting bigger, bigger, and bigger, and the data volume increasing rapidly as well. So basically, the data set is drastically increasing, and ideally, we always want to have the data AI bring to the data, but it's not always possible. So with all AI exists in the cloud, so the cloud become part of a lot of workflow. So this combination, the cloud WAN network, reduce latency and bandwidth constraint. So with the bandwidth constraint, you're talking about the view capability performance suffer as a result. So now you have a big data set, one thing. So the data set it's keep increasing. So it's significantly different than it used to be years ago when initially the compression was developed for the different data set, different type of network. So basically, as a result, what we're seeing is it's a slow loading of imaging, poor scoring, degraded performance. So this is affecting the end user. So the end user, for it's being radiologist and clinician and pathologist, waiting longer for the imaging, first image displayed, delayed. So this is basically become a more and more acute problem for the user. So basically, let's say if your images is running slow, then you're on the right webinar today. So there is 4 knobs here. So when you talk about the how to improve it, so you have storage, you have network, you have compute power CPU, and you have the user experience. So you have to figure out the storage of bytes. Bytes are cheap, but operational cost IOPS are not. So you want to figure out where the bottleneck is for your organization. So and you think about the user experience, it's combination, it's negotiation between storage, network, and compute. So all those like 3 knobs negotiate, and the user experience, either it's winner or casualty, depending on the result. So the performance, again, the storage performance over the year, the network and the compute power change. So which require to have new new compression to be able to support that. So to think about what right codec, what kind of format to use is like this is something that it should happen automatically on the background. You never met radiologists saying like, wow, great compression ratio. It never happened, but they do notice when the scroll is slow or fast. So those are the questions you kind of have to ask before you select the right codec. So is it lossy or lossless? So majority is clinical workflow. You can they lossless by definition, but there is certain workload that you need to think of, and that can be lossy, and that could improve your speed because you definitely want to show and you want to download only what needs to be downloaded, not some stuff that require for the archiving. So the not dominated cost is between storage, network, compute, where you want to invest to get the improve staff time, which is user experience. So streaming, it's important component. That's what we're talking about, is basically be able to progression, show region of interest in the right time, and again, download the data and request the data that you need. So it's going to be displayed on time. So, and from all those three questions, you decide which, as a middleware, what's the right encoding format. So historically, there is not that many choices. It's JPEG LS, JPEG 2000. For some data, you want to decide to go uncompressed if they're too small. If it takes too long to decode and encode, you might choose not to do anything. So those are decisions that has to be made. Pathology, it's really great example, and we are, as a vendor, we're getting more and more pathology installation and pathology workflow, which is it is digital imaging, but it is different from regular radiology, as another subspecialty as well. But pathology is significantly different. And here's the example of the whole slide imaging. So you see the slide that you can see the regular CT scan size, the dimensions, and how many studies. So if you're talking about the regular X-ray, it's around 10 meg. You talk about MRI, it's 25 meg per slide. CT scan is 250 megabyte, so it's bigger, but pathology, it's different magnitude. It's 2 to 4 gigabyte. And so if you talk about it, 1 to 4 gigapixels, so it's a resolution. Think about it as like looking at the mural, the big mural on the wall through the keyhole. So this is big, and streaming tiles, that's the way to go. You can't just wait for the full download and the whole thing. So the JPEG 2000, it's only decoding algorithm that allow you for the stream, but with compression, we know historically for the big data set, the slow decode result in a poor scrolling. So it doesn't matter what your compression ratio is. You might compress very well, but if it's slow to decode, that's what you get. So increasing latency during navigation when you deal with the cloud. So it also requires high compute requirement, the way it was designed in the 90s. So, and also it reduces the scalability. So the streaming is mandatory. So the key requirement, you can't download slide completely. So you have to download only stuff that viewer must see. So on demand. So think about it as it's a Google Maps. So when you click on the Google Maps, you don't download the whole planet. You just download the region of interest, like that specific location you're looking for. So this is the same example. So that brings us to the powerful feature for the JPEG 2000 versus high throughput 2JK. This is fairly new technology, but think about it, it's a JPEG 2000. So the way to describe it, it's kind of like same. You come to the coffee shop, it's the same quality coffee with more baristas. So you get your coffee, same quality, but much faster. And so which become important with the big data set and cloud. So the original, so you can see this slide kind of describe the main difference. It's the technology it use EBCOT and FBCOT, the fast block encoding, which become available with the new CPU and GPU requirement that, so it can encode, decode faster, and then you can even convert from JPEG 2000 to H2JK, which stands for high throughput J2K compression. So it's faster decode, reduce CPU per viewer session, and so more concurrency in the cloud. So what H2K delivers in practice for cloud and web viewer? So again, think about it. I really like that analogy. It's like more baristas in the coffee shop. So the high throughput JPEG performance gain. So this is the data that we actually we're gonna have our white paper come out probably in this month. So we're working this right now and formalize it with some of the we took some different data set and run how fast we can decode and compare with JPEG 2000 JPEG LS to see some real performance data. And so H2GK is optimized for the cloud viewing. That's just basically improvement from J2K for the faster decode speed. The main thing is the improve the decode encode speed, so improve progressive streaming support, and the basically to make sure the first image and decrease the lag per tile refresh for the smoother scrolling and zooming. So less waiting, few interruption, improve productivity. So when you're talking about, let's say, the good example is a pathology, the bigger data, the better result you see. So if you take the small data set, it's not as efficient as the big one. So it's specifically designed for the you'll see the real advantage when you talk about the big data set. So we took, like, let's say if we're talking about AK pathology image comparison, so decoding time difference, it's 8 times faster. So that's a significant for one slide if you think about it. So 390 millisecond versus 3 seconds. 3 seconds, it's long. So
in other words, Dmitry, what I'm hearing here is that JPEG 2000 actually provides more compression, which theoretically should make it faster to first image. But with HTJ2K, you're using more space, so it's a little bit less compression on those images, but the display speed is faster when it's
exactly
optimized for web.
Exactly. So this is the good point. Thank you, Florence. So when you talk about normalizing encoding during injection for the storing, yes. So historically, you think like if you can compress better, that's the most important thing. But we're talking about the storage. So with the web viewer, it's important that you can encode, decode faster, so you can get what clinician needs and on the right time. So like you don't want your coffee cold, and you don't want that later. You want it in the right time. So I, for example, I ran out of coffee beans this morning. Here we are. So this is this is important. So yes, there is with H2K, you progressive streaming. It's enable progressive streaming, faster loading. It's basically better performance, but it comes with a little bit of cost. When it compress, you can see storage versus performance trade-off on the right side of the slide. That if you talk the example of CT image, which is way smaller, that with the H2GK faster decode encode speed, it takes 29% storage, more storage. So you have to keep in mind that it will require more storage, not from raw data. We're talking about the raw from compared to the regular JPEG 2000. With MR, it's 38%. So the bigger the data set is, the less overhead is. And with the big pathology study, it's only 7%. Yes, you will require more storage. It's not compressing as much, but the trade-off is eight times faster for the for the big data set. So this is the trade-off you have to keep in mind. So that's why you need to know those details when you figure out what the algorithm for your compression will be for your specific organization based on your data. So recommendation, the general recommendation for the encoding strategy by use case. So again, encoding is critical performance decision and directly, in fact, clinical productivity. We talk about it. Your performance, scalability, and cloud readiness. It's important to think about it and how you. So compression is workflow decision. Remember, network, compute, storage, UX. So those are four factors. So generally, cloud viewing, it's obviously H2J2K. It's the way to go. So for the you want to use that compression, especially for the large data set. Pathology viewing, yes. Storage optimization, probably no. JPEG LS, it's still much better in compression. It's a simple. It doesn't require any streaming. So you probably, for the long term and for the storage, you want to keep JPEG LS. For the legacy compatibility, depends what kind of vendor you're dealing with. So you still want to use probably JPEG 2000 that they support and be able to decode on the fly. And some special cases you want to have maybe uncompressed Dicom. So this is the use cases that generically come to mind. So now let's be specific. So those general approaches important, but you want to think about what's your rollout checklist. Okay, what do you do in your organization to improve that? So you have different project with AI, you have different data set and all of this, and one size fits all. It's not always great. So benchmark with your real data. It's really important. So it's both speed up storage details. And so you basically start with one modality, one compression, and one viewer and see the difference, what you get. So it's like benchmark with your real data set and come up with the strategy. Benchmark is like it's like flossing. Everyone agrees important, but nobody does it until it hurts. So same with benchmarking. You have to do it with validate performance configuration with your own data and see what happened. So one site measure time first to image, CPU per session, and see what's going on. So
Dimitri,
capacity
Dimitri, let's do a quick time check. We have a couple of more slides to go through, and then we need to turn it over to Marius. So please go ahead.
Yeah, thank you. So the capacity planning is important. As Florian mentioned recently, storage is a concern. So you need to plan with more storage. Fallback strategy is important. Don't assume that every vendor will support this JPEG 2000 or even an H2JK. So you need to make sure that you can transcode on demand and keep dual format as necessary for some of their rollout. So those is the important factor to check. This is how I personalize this with Dicom System Unifier as one of the features that we have is basically with using Dicom System Unifier, you can convert incoming traffic as you inject to the H2JK, or you can convert as you send to the different, let's say if you send to the cloud, when you're talking about the remote, you add the remote. The remote could be anything. It doesn't have to be Dicom. It could be cloud, could be AWS, Google. We're agnostic which cloud to use. So you configure the syntax as high throughput. like everybody see my desktop, and this is basically as you save your settings, it's gonna be convert them on the fly to the H2JK. As another option, you can create on the receiver side. So an ingestion will store them in H2JK. As an option, you can definitely, again, back to edit. So you can configure the Dicom web endpoint, and you can configure as cloud, where you select your cloud destination and send to the cloud with this specific compression. It's really easy. It's all web-based. This is how you configure, and then you can see the performance and how fast you're able to move the images to the cloud. Coming back to the slide, so basically Unifier, one of the I would say we call our product Swiss Army knife, one of the blades. It's H2JK. So depending on your workflow and what are your vendors you're working with and how you want to create your compression strategy, you can enable certain features easily. So it's basically accelerate crowd migration, AI workflow, and other. So we're going to the ECR next week, and as you have more technical questions about this topic, about middleware, we'll be happy. MedDream will be exhibiting there as well as Dicom System, and we'll be happy to talk more about it and address any type of questions, concern, or talk more about this topic. So I hope we're on time. I'll let our next speaker, Marius, to talk about the actual viewer performance, and because how to have the middleware, it's important, but to have the right viewer that utilize all this technology, it's the most important, because that's what radiology then clinicians are using. So go ahead, Marius.
Hello, everyone, and thank you very much, Dimitri, and Florian, for very nice and detailed presentations, and we'll be looking forward for this white paper you are preparing. So it's really nice that you go so deep in this in this high throughput explanation. So I will share my screen, and I will just take up to 10 minutes to present what we are doing now on the MedDream end. So we would like to present you the MedDream and the AWS collaboration, and with addition of this high throughput transfer syntax. So in our traditional architecture, as you may know, so when we do the installation and we configure the packs or some storages, so basically the images first need to be cached before the user can view them. So we can do this on two ways: either on demand, when the images is being viewed by the user. So he logins to the MedDream viewer, MedDreams connects to the cloud packs or some storage, do the caching and processing on the backend, and then streams this data to the MedDream frontend, where the user can see the images. And another option is to have pre-cached data. So this means that if let's say a new study arrives to the pack, so it's possible to pre-cache this data in the MedDream backend. And to do this, you can use either EIN messages, Dicom routing, or our RESTful API. to do the pre-caching, and then when the user will open the MedDream and access the study, it will open it for him much faster. This caching process basically involves the pixel data extractions, the compressions to raw pixels, and some other things which MedDream needs to do in order to prepare the data and to display it in the front end to the user. And this image caching basically is the most resource heavy part of the system, and its drive infrastructure sizing and cost a little bit. And to support growing workloads, the system needs to be scaled. So it should be, let's say, additional servers or additional containers, depending how you deployed the MedDream viewer, or it might need, more powerful hardware for this traditional infrastructure architecture, which we are having now. But during the years, we have been working with AWS, and we have developed a next generation architecture that changes our current architecture. So the main thing which is changed is, instead of relying on heavy server-side caching, let's say, the pixels are streamed directly from AWS Health Imaging with one if they are stored in a high throughput transfer syntax. And the processing of these pixels are intelligently performed on the user device. So if we can see the diagram here on the right side, so when user access the MedDream connects to the AWS Health Imaging, and let's say these images are stored in a high throughput transfer syntax. So as we can see that we are skipping MedDream backend processing and caching, and we're going directly to the MedDream front end, where the compression and visualization occurs. And what are the benefits of this new architecture? So basically, you can reduce the infrastructure requirements. It will give you the lower operational cost, and it will improve the scalability for the enterprise deployments. It can access the uncached studies more faster, and decompress, visualize, and open them more faster. And I would say it is cloud native and future ready design, as we see that many clients now chooses go to the cloud, not to have their own on-site infrastructures, hardware, and so on. So I think more and more clients will be deploying and working on the cloud. So this new architecture, I would say, is quite promising. And in a few minutes, I will display you our demo version, which is being deployed here. And you can also always see our demos. You can open them and play with them. Dimitri, of course, made incredible presentations, going more deeply with the numbers and much more detail. So I'm just going to mark some points where we agree with the Dicom system, that of course the high throughput is the higher performance. It uses lower CPU. It's a high compression efficiency, and it is great fit for the cloud and for the large studies. And as also Dimitri mentioned about the pathology studies, which are very large studies. So we are also working on this direction. And in our next release of the MedDream, we are planning to have the support for the pathology, and you will be able to see the images. So stay tuned for our webinars for new releases, where we will present more about these new features. And now I want to quickly demonstrate you our online demo, which everyone can access on your computers. So in our MedDream website, if we will go to online demo, in the middle now we have another demo, which is new, so AWS online demo. Once you click it, it will automatically log in you, and it will show you the same demo studies which we had before. But this entire demo is deployed on AWS. All the images are on the high throughput syntax, and you can try, in your locations, open on your computers, to see how fast it loads, and how seamless is the workflow, going through series and everything, and to show you that this is actually high throughput. So as you can see, we have the transfer syntax of 202. This is a high throughput transfer syntax, and as you can see, we can scroll through series without any problems. We can load any studies just in, I don't know, in milliseconds, I would say. So it is very, very nice performance. So for example, opening the 3D image, 3D model, it also takes just a few seconds, and then the doctor can, open it and play with it, easily, and do all the manipulation and everything. So I invite you everyone to check our website to see how this is deployed, to see how the speeds and so on. And if you are interested, if you need some additional information, just contact our sales team and we will get back to you. So was my very short presentations of what we are doing and what we have done now regarding the high throughput and the MedDream, and getting back to you, Renata.
Thank you so much. Thank you for our presentation to our partners, Dimitri and Florent, and for my colleague, Marius. So I will share my presentation with the questions, and we will try to answer.
If I may, before we start answering questions, I think it's important to note what Dicom Systems and MedDream do together. What do we deliver for our customers? First of all, we have thousands of installs around the world, right? And every single one of those routers, even though they are not PACS, serves as a lifeboat image access layer, right? So the use case that Dicom Systems and MedDream serve for our customers is downtime PACS, right? Let's say your PACS is down for either planned or unplanned reasons. The most recent images are still available in the cache of the router, whether it's a cloud-based router or an on-prem router. You have in your router the most recent images that have been routed from the modalities and are on their way to the PACS of the VNA. And so it's an opportunity for us to provide an access layer to the physicians, even though we're not a PACS company again, right? But because we have those most recent images available, they can still access them and at the very least do a wet read until the PACS operations are restored. So I wanted to mention that that is the primary use case for our collaboration with MedDream.
Yeah, this is the good point to explain what we do together, why we joined this webinar. So MedDream has been our partner for a long time, and that's how our customers view their images. So
thank you so much. Thank you for clarifying. Okay, so the questions. So I'm going to read. Why is High Throughput JPEG 2000 not widely adopted yet?
I can probably answer that. It was recently, I would say it came out in 2019, 2020. So Florent made the joke, it's just because of the COVID. So we think that's the problem. So, but they just release in the wrong time. But anyway, I think it's getting adopted. It just anything is a compression. If you think about it, you need to have other system that be able to speak that language, right? So you need other system that be able to decode that as needed, and so that adoption will take time. So, for example, we do support it and MedDream, so we can and MedDream as well, so we can work together. But as we come to different organization, there is like hundreds of different vendors, and you need to make sure that it's all work together. So that's why adoption it's happening. It's just not as fast as you think. So, and for the imaging, it's fairly new, only 6 years, right?
Well, and I think it's important to note that it's taking time because it's not the only thing being tested by vendors out there, right? There's always a lot of testing, a lot of new technologies, a lot of new code being written, and not everything becomes a standard, right? It takes a long time for something to become adopted. And if it's working well, then you're going to tend to see more adoption, right? Dicom didn't become a standard for a while. It took a long time. HL7, same thing. It takes a while for vendors to come together and test with each other. That's why there's connectathons, and not every candidate for a new technology makes it into the mainstream. And so I think HTJ2K is starting to show real promise, and I think you're going to see a faster adoption curve. But it's like anything else. It takes time, and honestly, it should take time for us to prove out the stability of this, because after all, our job is to present medical images, and that means patient safety is at risk if we cut corners to validate new technologies. And I think it's on the right track.
Thank you so much. So next question. When MedDream is planning to implement pathology support?
So as I mentioned it in the presentation, so our plan is to have the first, let's say, implementation of pathology support is in our next release. So maybe in a half year, maybe earlier.
It will come in 8.9 version, which will come sometime in June or beginning of July.
Yes.
Okay, thank you. Another question. How can I deploy MedDream on the cloud?
Oh, in many various ways you can deploy. So you can deploy on the standard virtual machine. You can deploy on the and on this Docker, Elastic Docker service, on Kubernetes. So basically, we can work on many different options depending on what your knowledge and what is your preference, I would say.
Okay, thank you. Another question. How is the adoption of HTJ2K in the Dicom community?
Well, I think we answered that question in the first.
Slow.
Yeah.
Okay, so I'm
Steady
moving.
and slow.
Yeah. As everything else, yes.
Okay, so I'm moving to the next one. How is the MedDream JPEG lossless setting compared with this?
I would say faster with
Yep,
high throughput.
the first thing, if it's not JPEG 2000, JPEG high throughput transfer syntax, we always decompress from any transfer syntax to raw pixels and gzip them. So in principle, we are streaming gzipped raw pixels. So the performance with high throughput is much better. You don't need any additional steps, and the size in principle is smaller.
Okay, thank you. I'm reading the next question then. How hard is to convert from H2J2K from Dicom 2000? The idea is to store the study first in H2J2K and at 2-year plus mark convert to JPEG 2000.
It's not hard. As a matter of fact, it takes less time to convert from Dicom 2000, JPEG 2000 to H2JK and vice versa. So, but you want to plan and figure out, depending on your storage, what do you want to do. I think it's a good plan to have 2-year mark convert to JPEG 2000, and at some point for the long term, you might even use JPEG LS, depending on what kind of data we're talking about, and I would say pulling the prior rules and etc. But yes, it's not hard. It's part of the library. You can use. There is some freeware library, but Kakadu. Once we release our white paper, you'll see the real statistic using different type of library and how fast it is. So, but it is it's not hard. It requires some CPU cycles, but that's what planning for. So, and I think we went through this through the slides already. But so let's move to the next question, Renata.
Thank you. So the advantage is faster visualization, but more storage capacity needed. But isn't the enormous demand for additional storage exactly that's slowing down the adoption of digital pathology? Is there a way to convert to JPEG 2000 for long-term storage to save on storage?
Yes, as we answered in the previous question, there is a way, but if you think about it, we're talking about only like single-digit percentage increase in storage for the big data. They only for the big data set, like for the pathology. For the CT, MR, yeah, it's significantly higher. It's like 20% or so. So you have to plan that accordingly. And so for I don't see why you need to store H2JK for the long term. So for the long term, you can use other compressions that's more efficient for the storage, and for the short term, for the viewing, you can use that. So you have to plan accordingly which compression and codec to use. But conversion from one to another, it's possible. Just again, on the fly, it will take more time and resources, so you get account for this.
Next question. This compression is lossy, no? It is approved for primary diagnosis?
It can be lossy or lossless. That's depending how what you choose. So if your requirement it's only lossless, that should be lossless, and you never use lossy for the primary diagnosis. This is something that your organization choose. So if you mark checkbox to be lossy, it's going to be lossy. So we usually, but that's the decision that your organization has to make. And usually it is, you're absolutely correct, it's lossless. So.
Okay, thank you. Another one. Our attendee wrote, I see Dicom committee just released, said that the H2J2K is supported as encapsulated format. Is there a native compressed format?
I'm not sure I understand the word native, but Maris, maybe you know what they're talking about, but
not so much.
Yeah, I think it's it is.
I think it's not encapsulated. like normal pixels, like other transfer syntaxes.
Yeah, it's not like PDF or whatever. That's just the part. It's the same as JPEG, as I said. There is no difference in terms of technology, just the different. It's much faster decoding and encoding. So, let's move to the next question.
Okay, thanks. It is possible to post-process both images. What about 3D reconstruction?
Not sure what does it mean, but since our 3D reconstruction is done in front end, so there is no way to do pre-processing on the server. So you need to download all pixels in the front end and pre-process them. We have a communication API which allows you to preload some studies in advance if you know workflow. Then the 3D reconstruction will be shown much faster.
Okay, thank you. I go to the last question. If somebody likes to ask something, write your question now. With the new H2J2K option in MedDream, is the decoding done on the client and the performance related to the client resources?
Yes, this is correct, but decoding from high throughput does not require a lot extra resources like normal PCs or even mobile phone has. So in principle, for example, with JPEG 2000, you would require much bigger resources in order to decompress them on client side. So we choose this transfer syntax mainly because the transformation are quite fast and does not require heavy resources on user's machine. A normal mobile phone, you can try our website on AWS, open from your mobile phone and try to see that we are opening imaging without any need for extra resources.
Yeah, this demo you can find on our webpage. Just click online demo and it's going to be a live demo on AWS option. So I think this is all the questions we got today before webinar in the registrations form and during the webinar. So thanks a lot for our attendees for your activity. And if you have more questions and you want to contact us directly or our partners, Dicom Systems, in the bottom of my slide, you can see the contact emails, or you can just email directly your sales accountant in MedDream if you have one. So and also, as Arturas mentioned, you can try on live demo by your own. So I'm using this opportunity also to invite you to visit MedDream. And as Dimitri mentioned, we are going to be in ECR on March. So you can write us to the info@meddream.com email and set a time for a meeting, or just pass by and step by to talk with our team. And also straight after the ECR, MedDream will be in HIMSS in USA, as always, these two exhibitions. And also today, our team is debuting in Viva exhibition in USA. So if somebody from you are planning to visit Viva this year, look up for MedDream booth. And I think this was all for our webinar today. Once again, thank you for our attendees, and thank you very much for our partners, Dicom Systems, Dimitri and Florent. Thank you so much for this educational webinar, very useful.
Thank you.
Thank you. And for all the attendees, you will get the video recording in upcoming week, and also with merged presentation from both sides, MedDream and Dicom Systems. So thank you all very much, and see you on our upcoming webinars.
Thank you. Bye.
Bye, everyone.
Everyone.
Thank you.
Bye-bye.
Bye.